The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
Ladies and gentlemen, welcome back to another episode of Cosmic Catastrophe on Revolution.radio. I am your host, Diamond, from the Oppenheimer Ranch Project, and joining us today, as usual, my partner and co-host, Leah Shaper.
Hello.
Welcome to the show. It's going to be a banger. Well, you do know about two of the topics. I'm throwing in a third topic, but you'll probably be familiar with it in the middle. Yeah. We're going to start off the show and discuss why Mount Rainier is keeping scientists up at night. And then we'll jump into a headline that has hit the media over the last week. Heat is the #1 killer. And we will show you all the stats. Well, I couldn't find any statistics showing that, so I don't know where that came from. But just typical gaslighting from the mainstream media. The second half of the show, we're going to be talking about the weakest magnetic field on Earth, 30 times weaker than it is today, and its implications to life on Earth. This is a time period called the Ediacaran period, between 600 and 540 million years ago. And right after this is when all life exploded on Earth. So we'll talk about that. It's kind of interesting. Are you ready to go?
I'm ready to go.
All right, let me share the screen and let me know if you can see.
I can.
The glorious Mount Rainier in the distance. And I guess that's Tacoma. I don't know if that's Tacoma. Yes, the city and its tombstone, it says in the bottom, but what city is that? Oh, that's Seattle.
It is Seattle?
Now,
okay.
Seattle is way far away from Rainier. In order for Seattle to have any effect from a volcanic eruption at Rainier, it would have to be significant. And we'll go over the entire volcanic history of Rainier to bring you up to speed. But why Mount Rainier is the U.S. volcano that troubles scientists the most. Did you read any of these articles?
I did. And I also was looking into a few other things and realizing that it's not just the volcanic potential of Rainier, but also just the potential for those Lahars to slide.
Excellent.
With volcanic activity or not.
Right. So a Lahar, in order to form a Lahar, you don't need an eruption. You could just have some heat up at the top of a volcano and it would melt. Now, this is interesting because there's a similar volcano called Nevado de Ruiz. And in the mid-1980s, it's shaped just like Mount Rainier. It's further towards the equator, so it's much warmer and there's much less snow and ice. But a small event on Nevado de Ruiz in 1984 caused massive lahars down the sides of the mountain, killing everyone in the valleys. And that type of scenario is what scientists are worried about here on Mount Rainier, where there is 6 times the amount of glacial ice and snow as that mountain. So a tiny blip of an event on Rainier would cause catastrophic lahars. Even if it doesn't reach Seattle or Tacoma, there are tons of cities in the way.
USGS has a little video on YouTube, and maybe we'll put this in the description box later, that models what would happen if these lahars slid, and some of them do go right into particular communities. The other thing that I find kind of amusing about this, I mean, this is not really an amusing situation, but what I do find amusing is given all of the hype about global warming, especially in this part of the country, you would think that people would be talking about the potentials of glaciers melting and then causing these lahars to slide and how much of a danger that is. But I don't hear anybody talking about that. Maybe I've just missed it, but.
Well, plus we don't live here, so we don't know what they're being taught in the public schools, let's say in in the areas near Mount Rainier. I'm sure most of the people are aware of these mud flows, but think about it this way. Seattle, the city, was built on a 100-foot thick Lahar.
Right.
So that means there is a chance that the city of Seattle could be struck by a Lahar that's 100-foot thick.
Yeah.
That would be loss of everyone would die.
Well, not only that, but, obviously there are established river valleys coming down Mount Rainier, right, which automatically provide the route for a Lahar. And then if you watch this simulation done by USGS, often the Lahars go into particular communities and arrive there within like 15 minutes. And they're talking about, you should be prepared and aware. And if one of these starts to slide, you have to get up at higher elevation immediately. But I'm sorry, I don't think anyone's reacting that quickly.
Exactly. Now take a look at this map. It shows Mount Rainier, and the pink area in the center is where the furthest extent of any lava flows that have ever occurred in the last 200,000, 300,000 years since Rainier has been active and building. The danger zones are red and yellow. Those are the most dangerous areas. These are areas where volcanic mud flows have traveled down valleys in catastrophic ways. These lahars are similar in consistency to concrete, liquid concrete, and inside of them is the debris of everything that they encounter on the way down the valley. So it's like a network of trees, debris, rocks and debris in concrete moving at this 60, 70 miles an hour down these valleys.
Right.
And a small event, not an explosion of Rainier. Let's say if there was a small eruption, a tiny one under the glacier at the top, no one would see it. The entire top glacier would melt, and then these lahars would run down the side of the mountain because it would boil the water on the top, and that boiling water would then hit the snow. It would catastrophically melt and run down the side. Let me show you what I'm talking about. Here's a close-up of one of those communities, the closest to the mountain. If a small eruption occurred at the top here, you're going to have lahars that run down these valleys rapidly. Look at this. They're all going to accumulate here. All of the mud flows, they're going to rush this way, and watch what it does. It makes a right turn here, and it enters right in here.
Mm-hmm.
And that is what you're saying is this is a close, within 10 or 15 minutes, this entire city is covered in mud.
I think in particular, I remember Ashford, which is shown on that map.
Right here.
Being the Lahar is going to reach that easily in 15 minutes. And then, on top of that, what's your warning signal? Like, how quickly does the warning signal come in? The
Lahar
does
warning
anybody
signal?
even know that it's coming in 15 minutes?
I don't think there's a Lahar warning signal. They have tsunami warning systems here for large earthquakes.
I do remember again in that USGS video some mention of some amount of warning signal set up, and I don't know what the method is at all.
It would probably be gauges in these valleys by the creeks. They would immediately know if there was a surge, but that would mean the Lahar has moved down the mountain into the valley and is now being detected. So that would give you even less time to get out. 5 minutes.
Yes. And they also were certainly not saying that there are extensive warning systems in place. Like the way that it was phrased, it made it sound like, well, there's some warning system in place, but it's really not adequate, is the impression I got.
What's interesting, if you take a look at this map, take a look at the Puyallup River and the Carbon River. Do you see them up in the northwest of Mount Rainier here?
Okay, yeah.
They must be so steep that the Lahar does not form anything here, but it flattens out as it reaches Tacoma, very wide.
Mm-hmm.
We're talking in this area 2 to 3 mile wide Lahars. If that ran into Tacoma, can you imagine?
Yes. The USGS simulation also shows the depth of what the Lahars would be. In some places it's only going to be like 3 feet. In other places it's going to be like 20 feet.
Yeah.
So that's another consideration. And obviously if it's in a narrow valley, it's going to be a lot deeper.
Yeah. So the towns of Packwood, Ashford, Randall, Elbe, and Carbondale, as well as Orting, are closest to proximity. Don't leave out Greenwater. And these are all at very high risk for Lahars. And it's not a question. It's funny that we have to keep saying things like this. It's not a question of if, it's a question of when. This is an active volcano that erupts every 500 years historically. And let's bring up the data, shall we?
Yeah.
All right. So the eruptive history of Mount Rainier goes back about 600,000 years. Here's a graph showing the Mount Rainier growth stages. So around 600,000 years ago, in this area of Cascadia, something happens. 500,000 years ago, there's a dike event and the volcano begins to build. And here we are today. So what's happening in the Holocene at Rainier? It's still active, and it's listed as one of the most hazardous volcanoes in the US, and it's on the active list. So here is the Holocene eruptions. These are years before 1950, and it only goes back 3,000, which is plenty of time to go back. You can see around 2,700 to 2,700 years ago, Rainier was a firecracker.
Yeah.
It erupted 9 times, 8 times. Yep, 8 times in that period in 700 years. And then it kind of calmed down in about 1,500 years ago. In 500, there were 2 explosive magmatic eruptions, which produced tephras and lahars, but no lava flow. So here you just have a big explosion. It melts all the glaciers catastrophically, and everyone living in the valleys is dead.
Right.
Can you imagine that? I didn't look up any Native American folklore on these lahars, but there has to be.
Yeah. Yeah. Well, and I mean, this data set kind of makes it look like Rainier is slowing down, but it's not really big enough to actually determine that. And then I'd love to know what this color coding here is. I guess it appears to be the extremity of each event, maybe.
I don't know what the color is, to be quite honest. Red circles designate eruptions with direct physical evidence. Orange circles represent possible eruption documented by uniform class type in the White River confluence Lahar, and light blue represents reported 1894 eruption. So this isn't just an account, and there's no evidence for it.
Oh, interesting.
Yeah. But if it was just a small puff and seen from a distance, there would be no evidence for it. If there was no Lahar or, anything. If it happened in the summer, who knows?
Yeah.
But what you can see here is that there seems to be something happening every 500 years. And all of these 500-year events are linked to Lahars. The last one was about 420 years ago. Possible small magmatic eruption leading to Lahar. There were no lava flows, but there is the electron mud flow. So there is a Lahar here. 1,000 years ago, there were White River Lahars, no lava flow. So you don't need a lava flow to get a Lahar, just a fart from the mountain.
Right.
And that's what they're worried about. Because if this happens in the middle of the night, no one sees it, that is bad news.
Yeah.
An alarm goes off at 3 a.m. You wake up, you're like, what's that? I don't know what that is. You have 10 minutes.
Right. And normalcy bias, even people who live in areas like this who are aware of the danger, there's still this, psychological thing where you're like, oh, that's not going to happen in my lifetime or something like that. So people don't react quickly as a result because they don't live with the idea every day that this is a real danger in their lives.
Yeah, and I don't know why they're focusing on Rainier. Maybe they know something we don't that's happening. But take a look at the Pacific Northwest. We've had all this activity up here in Cascadia that's scaring people. And then look at this. The most earthquakes since the last eruption of Mount St. Helens is going on. There's been 131 earthquakes in the last 30 days at St. Helens. Why are they not talking about St. Helens?
Right.
Mount Rainier's just had a few earthquakes here, 23 in the last 30 days.
So the media piece that triggered us talking about this came up recently?
Yeah.
Okay.
Yeah, about a week ago, and then everyone ran with it. So it's like all over. All sources are talking about Mount Rainier and scientists worrying, and then CNN got hold of it, and on and on.
Well, it may be the focus is more on Rainier simply because by its nature, by its very height and size, and these Lahars is an extremely dangerous volcano.
Yeah, and there's not a lot of big cities near Mount St. Helens.
Right.
And the Lahars would just like dump down in here into areas where there aren't very many people.
Right. Right.
Nonetheless, take a look at the activity up here on St. Helens, all centered directly here where the flank eruption occurred in 1981.
Wow.
So the activity is right below where that flank collapsed and at the summit caldera as well. Very tight grouping. This is definitely magma underneath the here refilling, and something is definitely recharging there based on how tight that is. You come over to Rainier here, and there is some stuff going on here on the flank and up at the summit. But look at the general seismicity is from far away.
Yeah.
See it all surrounding Rainier?
Yeah.
So I wonder if there may be some magma over here that's moving into the system.
Yeah.
But with the number of quakes that are here at the caldera and the side, remember, just a tiny burp of this volcano could trigger these lahars.
It's just astounding to me that we as human beings continue to live near dangerous volcanoes and continue to develop like nothing will ever happen. It's so bizarre.
Yeah, and look at the distance here from Seattle and Tacoma to this mountain.
Yeah.
It is very far away. So
right.
Just like the picture at the beginning here, you're not really thinking that this can affect you.
It's like a false sense of safety. Yeah.
And even in the event of a VI5 eruption, the general weather pattern here is west to east. These cities are all west of the volcano. So they're just going to watch a pretty explosion from a distance.
Well, but a place like Seattle, I mean, really where the danger for Seattle will be something like, let's say you have a major Lahar and it starts cutting off transportation routes, and now you're going to have a supply problem.
Yeah, so even a small Lahar could do that.
Yeah.
Yeah, it's very interesting that so many people live near these threats. I don't get it.
Yeah, I don't get it either. I mean, you and I, when we made a decision to move out here, that decision was very much partially based on the geological safety of where we are. You know, like that was a
we checked
decision.
Everything. Like they're really, this is like the safest place from tornado, from any kind of severe weather. The hail never gets above a half an inch, let's say. There's only been
that's
one
not
recorded.
True. We just had we just had hail with 1 inch hailstones a couple of weeks ago.
What I'm saying is there's not the correct dynamics for gorilla hail here.
Yeah.
That will never happen. It happens on the other side of the continental divide.
Right.
And then geophysically, there's no faults, there's no volcanoes, there's nothing that's happened in this area for thousands of years that would be any worry.
Right. And even like...
So you say, hey, let's move next to Mount Rainier that just erupted a few hundred years ago. Right. Sounds like a great idea. It's so beautiful, though. Like, that's so stupid.
Well, I mean, maybe
there's a lot of beautiful, safe places.
Right. I believe that we live in one of the most beautiful places in the country, as far as I've seen, which isn't everything. But I mean, we are very blessed to live with the beauty that we have here.
And it's amazing that some people who grew up here don't even know that.
Yeah, it's weird. People who live in town and have like never left town. Like we knew a guy who had never noticed or seen a bald eagle, and there are bald eagles everywhere here.
And he was in his 60s.
Right. And he's been here his whole life. Like if you want to see a bald eagle, this is a great place to be because you'll see one.
And then he was like, how did you know that? And
right.
I'm like, it's a bald eagle. It's the national bird.
Right. Well, I mean, I think that this is a common phenomena where, you know, you grow up in a place and you kind of take for granted what's there. I don't think that that's all that unusual, but I do find it kind of strange given how stunningly beautiful it is here.
So the eruption of the Nevado del Ruiz volcano in November of 1985 devastated the town of Armero, Colombia, when the Lahar killed more than 23,000 people in a matter of minutes.
Wow. What an awful way to go, too. Just getting swept up in like a mudslide and then
And look at how the
suffocating.
buildings get crushed into smithereens, so you get smashed to death too. It's like
Yeah.
dying in a stampede.
Yeah. Plus, you probably suffocate.
Yeah, if you're buried in the mud, yeah, exactly. Asphyxiation. Can you imagine 23,000 people? I assure you that the number will be much higher in Washington state if a major Lahar moves down those valleys.
Yes.
All right, so heed the warnings. And if you live in any of these places and have the ability to move to a safer area, that just could be your safest bet.
Yeah. Well, look, it's so interesting too that there's not much as far as population centers to the east of Mount Rainier, which appear from this map to be safer from the Lahars.
Yeah, but they would be covered in the most ash.
Right. Right.
So you not only have this volcanic threat up and down the western seaboard, which begins all the way in Southern California with Long Valley and huge super volcanoes and hotspots. It goes all the way up into Alaska. This is a continuous chain of dozens of active volcanoes, and people tend to live near them. Makes no sense. And the majority of the population is between the dangerous volcanoes and the ocean, where Cascadia subduction every 300 years moves and delivers an 8.5 or 9 magnitude earthquake and deadly tsunami. So it's like this is a recipe for failure.
Yeah, pretty much. We're so short-sighted as human beings. It's like, oh, it only happens every 300 years, whatever.
But it's going to happen.
Right.
Well, it's like kind of like my brother. He lived near the ocean, and a hurricane happened to come right where he lived.
Right at sea level. Or below? Isn't he below sea level?
No, he's right on the river, so right at sea level.
Yeah.
Probably 5 feet above sea level. But the storm surge was 15 feet, so his house was 12 feet underwater.
Right.
And then what does everyone do? They rebuild, and then in a few years they forget about hurricanes.
But at least he rebuilt on stilts, correct?
No, they built them the same level. And then he sold the house. I sent you the listing.
Yeah.
They moved to a higher level.
Right.
Yeah, people like to live right on the beach in dangerous areas where bad things can happen. That's just the way it is.
Why would you not rebuild on stilts? I don't get that.
Because all they did was they kept the house. They just put new drywall up. A lot cheaper than making a whole new house.
Right.
And so it goes. All right. So anything else we have to discuss about this?
No.
All right. So things are heating up. Mount St. Helens has the most earthquakes since its last eruption. And they're talking about Mount Rainier being a danger, and they both are. So heed the warnings and learn the warning signs.
Can you jump back 2 images there? Why are these squares in the Cascadia fault zone different sizes?
Magnitude of the earthquakes.
Okay. That's not color coded?
The color is the last 2 hours, the last 2 days, or the last 2 weeks.
Okay.
And this is not really on the Cascadia. This is on the transition zone, the mid-ocean ridge right outside of the Cascadia.
Mm-hmm.
But still, all this rumbling near the Cascadia worries people.
And it's significant rumbling too, apparently.
It went up to 5 magnitude last week. 6.4.
Yeah.
On the 7th. So that's a week ago. And then these are all aftershocks, obviously.
Right.
Yep. So that's what's rumbling. Let's move on to the gaslighting.
Propaganda.
Heat is the #1 killer. Here's the headline. America's top weather killer is not tornadoes, flooding, lightning, or hurricanes. It's heat.
Nonsense.
And so a quick search. This is deaths over time from 1999 to 2020. And there was a moment here in 2005, 1 year, where heat deaths exceeded cold deaths. But you and I have covered the statistics on cold deaths worldwide, and it's 5 to 10 times more people die of cold than heat everywhere.
Yeah.
Here's deaths due to natural temperatures, where blue is cold. And you can clearly see that the older you get, the more you die from cold than heat.
Yeah.
And here are all the places people die from cold. Guess where they are? Where it's really cold. Like Maine, Vermont, North Dakota, and Montana. So if you get drunk and leave the bar at 3 a.m. and pass out, you're dead in Montana, especially if it's February.
Yeah.
That's what's happening there.
Why is New Mexico so high?
Because it gets really cold at night in the winter.
Oh, yeah.
Like Taos Valley and all that. It's like minus 20.
Yeah.
Yep.
Yes. I was out at Chaco Canyon in January in, I don't know, 2011, 2012.
Freezing.
We had what?
It was freezing.
Yeah, well, we had a car issue, and we're going to be stuck there potentially overnight, and it was very concerning because I was prepared, but my mates were not, with as far as clothing was concerned. But we ended up getting lucky and getting rescued, so it worked out. But yeah, it was getting cold very, 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 very quickly.
And you got rescued by the natives.
We did. We got rescued by the natives. It was just happenstance and very good luck, and we were very grateful.
So in the U.S., cold and heat deaths are not as disparate as the rest of the world. They're close. But if you look at this graph, it's double the amount for cold to heat. So there are 2 times as many die from cold than heat in the U.S. annually, typically. There are some anomalies, but they're anomalous years, like 2011 and 2005. But if you look at a bigger data set, it's clear that heat kills far less than cold all over the world. Here's a graph of Europe and every country there, and you can clearly see the cold European countries. Cold deaths are eclipsing heat deaths in Latvia, Lithuania, Bulgaria, and Romania, as well as Hungary. These are all the countries that get tons of snow and tons of cold air.
Well, it's interesting, too, that places like the Netherlands and Switzerland are not, well, I guess they're not super cold. So I was wondering if part of this is, okay, like, so in the example of New Mexico, there may be people who are less acclimatized to cold as well. That could be part of the equation.
Right. And when it gets cold, they're like, wow, I didn't know it got cold here.
Right.
Okay. So excess deaths, hot and cold here, looking at it at a different angle. Take a look at the UK.
Yeah.
43,000 cold deaths versus 1,000 heat deaths.
Yeah.
So it's 43 times more cold deaths than heat deaths in the UK.
Wow.
And the headline is heat is killing us. I think we can easily prove that is a false narrative.
Yeah. There's been a lot of rumblings in the news about this lately, and it's obviously just another, stirring up of propaganda to get people freaked out about climate stuff.
The most telling data set is the one you're looking at, climate-related disasters and deaths. And this comes directly from the International Disaster Database, OFDA, CRED. Those are the 2 groups that compile this information. And I can't believe that the climate narrative has lasted 3 decades. It goes all the way back here to the 80s, right?
Mm-hmm.
And look at what's happening in the real data set.
Right.
Global deaths from floods, droughts, storms, wildfire, extreme temperatures have decreased to almost 0.
Right.
But it's the most wildfires ever. What'd you say?
Since the 20s. In 100 years, that's really dramatic.
Yeah, but it's the most wildfires ever. It's the hottest year ever. The sea level is rising. If we don't cut CO2, we're going to be dead in 12 years. We've never been safer from the climate. Look at this graph. It's absolutely insane.
And it really goes to show how suggestible we are as human beings, versus our inability to objectively assess our situation versus what's actually happening in the world. It's such a dramatic difference in how susceptible people are to this propaganda. It's mind-blowing to me. Like I think I talked about this on the show once before, but I have a former friend from back east who in some Facebook post a couple of years ago is completely hysterical about, this is somebody who lives in California, completely hysterical about heat, claiming it's 125 and she has to hang blankets in the windows and it's like hell on earth. And it's like, what? First of all, even if it's really hot where you are, that doesn't mean that it's really hot everywhere. Just because you are living in a moment of hell doesn't mean it lasts forever, nor does it mean that that's what other people are experiencing in other parts of the country or the globe. It's so bizarre to see people act like that.
Actually means that it's cooler somewhere else.
Right.
The Earth is a closed system. We don't gain or subtract energy through space at any appreciable amount. So the system is closed, meaning if it's hot over here, it's got to be cold somewhere else. You can't heat everywhere.
Right.
And the climate crazies are so brainwashed that even if, and this is a thing, even if you show them this graph, in their mind, they don't believe it. They think that more people are dying, wildfires are increasing, the sea level is rising, and all Republicans are bad.
Well, and the rationalization for not being affected by data like this is part of the propaganda and the narrative as well, right? Because like I imagine you show someone who's hysterical about climate data like this, and then they'll just come back and say something like, oh, this data is right-wing propaganda, because that's what the media has trained them to think.
Yep. Yeah. And then they just send it down the memory hole and erase it from the internet.
Right.
Yeah. So if you're out there and you're scared of dying from floods, droughts, storms, wildfire, and extreme temperatures, the chances are 0.
Yeah.
Now, if you were alive in the 1930s or 40s, it was a very high likelihood.
Sure. Yeah. Because it was really freaking hot then. And there was a lot going on. We had the Dust Bowl in the 30s. It was extraordinarily hot. Yeah.
No
also,
air conditioning. Now we have
right.
air conditioning everywhere.
Now we have air conditioning. We have better forestry management today than we did in the past. That makes a big difference.
If we keep going along with this green agenda, air conditioning will be banned.
Right.
It draws far too much energy from the grid, and we can't afford it. Do you want the sea level to catastrophically rise? Go ahead. Use your air conditioner.
I just saw today, I don't remember where this was published, but there's some article published somewhere basically saying that your own breath.
Oh, you sent it to me.
Did I?
Yeah.
Is contributing to climate change. But in other words, the narrative is feel guilty about existing and you should just maybe kill yourself. That is I really believe that is the motivation behind making headlines like that you should feel completely guilty for existing.
Well, and if you want to kill yourself, you just have to move to Canada. I mean, it's totally legal there.
Right.
You just say, I'm depressed because we're all burning up and I need to die.
Right. It's so, honestly, that makes me livid and so sad to know that there are people who, I know someone who responds to stuff like that, like propaganda like that, with a guilty heart. And it crushes my heart to see someone allowing themselves to be influenced that way, that they're so willing to just hate themselves because they think that their very existence threatens the rest of the planet.
Exactly.
It's the same thing. It's the same thing that's going on with, screaming about racism and how horrible white people are all the time. It's the same motivation behind that. It's meant to make you feel guilty for existing.
Don't do it.
No.
None of this is your fault, folks. Throw your television out the window if you already haven't and stop watching the mainstream media. It's designed by the deep state, the CIA, to misinform you. It is designed to divide humanity. It is designed to keep the slavery system moving forward as they extract wealth from each and every one of us. And the highest elites, the top 0.001%, they're the ones that win, and we all suffer.
And it's designed to destroy your mental health and your emotional well-being. It's meant to make you feel tremendously afraid and guilty. And the reason for that is that if you are consistently afraid and feeling guilty and confused about what's actually going on and what reality is, well, guess what? You are now extremely brainwashable, which makes you very easy to control. And that's the whole point.
Oh my.
It's the same reason for all of this gender ideology garbage and why it's targeted at children, right? Because you confuse children about the reality of biology and they become extremely malleable.
Well, I certainly hope some big shift is coming or a wake up. And I think it is. And this is a terrible subject to discuss as far as bringing up your mood. The world's self-esteem has been destroyed by this brainwashing.
Yeah.
And the fact that you can see these mentally ill people wearing masks and how fearful they are in the supermarket, it's just so sad.
It's even sadder when it happens to people that you know and love and you see it happening. And then there's not really anything that you can do about it because people don't see the reality until they're ready to see it.
All right, let's change the subject to finish you up on something.
Happy.
No, this is going to end terrible. We're talking about the magnetic field being weak, which is happening right now. So the article I saw was released in May of 2024 from AAAS, which is usually a propaganda machine.
Yes, very much so.
But this one is more scientific and factual because it has to be in what it's actually showing. What they did here is some mineralogy work. Very fascinating. It would take too long to explain, but they used plagioclase crystals. These are feldspar crystals. I'm sure people have heard of that. Plagioclase is a particular type of feldspar. But what it does is it has a very high resolution magnetic clock inside that locks into the crystal lattice the magnetic field of Earth at the moment it forms. So as this lava is cooling and the plagioclase forms, it shows the field, the direction, and strength. Absolutely fantastic. And so they looked at 21 plagioclase crystals in the Ediacaran period. That is between here, they're looking, that's between 600 and 540 million years old. And by looking at these feldspars in between this time, they located something quite unusual. A reduction in Earth's magnetic field between 591 and 565 million years ago. Such a significant reduction, it was 30 times weaker than it is today. Now, when you read this, what were your thoughts?
Well, I actually went and I read the actual paper that is associated with this article.
Yeah, we have that. I'll pull that up. Where is it? Near collapse of the geomagnetic field may have contributed to atmospheric oxygenation and animal radiation in the Ediacaran period.
Right. So one of the premises of this is that because the magnetic field was so weak, that it essentially caused the release of hydrogen out of the atmosphere, which then increased the concentration of oxygen, which then facilitated great diversification in animal evolution. So that's really interesting. And what they're talking about is a period of like 26 million years where the magnetic field is really weak, which...
Yeah, no, let me explain what I think is happening there with the hydrogen loss.
Okay. Because
So
I want to say, when you're done with that, I want to say something about the 26 million year period and their evidence for that.
Oh, okay. So if it is 26 million years and the field is extremely weak, we know one thing in modern times: during weak fields, geomagnetic storms coming from the sun affect Earth in larger and greater ways.
Mm-hmm.
So if this field is 30 times weaker than today, geomagnetic storms would literally hit Earth and I think strip the ionosphere and atmosphere off. And at this time, the atmosphere is like 98% hydrogen.
Mm-hmm.
In the early days here in the Precambrian and the Cambrian, which is why there's nothing living on land. There's nothing on land, not even a bacteria, because there's no oxygen. And so during this period, if you're stripping off that hydrogen, something has to replace it. And the only thing that you have to replace it is the surface of the ocean. We know that the ocean outgasses CO2. If you change the CO2 level in the air, the ocean will compensate and outgas it. So while stripping the hydrogen, the ocean is trying to compensate for the loss of material in the atmosphere, and it's evaporating.
Right.
What's in water? Oxygen. Hydrogen and oxygen.
Yeah.
And so I think the oxygen builds over 26 million years.
Yeah, it's interesting. Well, because then the other element of that too is going to be with a weak magnetic field, we're going to have a lot more UV radiation as well, right? And we've talked about that many times as very likely being a trigger for evolutionary change. So that would be another factor in this equation that this paper doesn't actually mention. But I'm a little bit skeptical about this idea that the field was weak for 26 million years, because I find when I read this paper that the correlation that they're making is very, very loosey-goosey, right? So, they take some samples from 2054 million years ago. I'm not really sure why that's exactly relevant in this situation, but I guess partially to show the difference in the magnetic field, showing that the magnetic field long ago... What?
Why they said it that way and not 2 billion years is
I know it really annoys me, and I feel like when I say something like 2,000 million years ago, I feel like I sound like Joe Biden, saying 1 million billion trillion dollars. It's like it sounds ridiculous. But anyway, so I'm not misspeaking here. It's just a weird way of saying this. So I mean, okay, so it seems that the reason for including those samples in this paper is to say, look, at 2,000 million years ago, the magnetic field was also about 30 times stronger than it was later when in this other period that we're talking about. And then they take samples for 591 million years ago in Brazil. And then they compare that to samples at 565 million years ago from Quebec. So, I mean, these are pretty isolated, right? Two very different places on the globe. If you look at a map of magnetic field strength on the Earth at any given point, like even today, there's going to be areas that are much stronger than others, potentially. So, to me, this isn't like, and also that's a long stretch of time. It's 26 million years. We don't really know what happened between 591 million years ago and 565 million years ago in Brazil and Quebec. You know what I mean? It's very loose. And then they go, okay, well, we do know that the amount of oxygen on Earth between 575 million years ago and 565 million years ago was much higher. So this is a really good correlation. That's what they basically say in here. I think that that's very loose. A lot of things.
This is the data set. What were you saying?
I thought you were going to say something just now, so go ahead.
No, clearly something happening here at the time in question, and we do know oxygen is increasing, and so the field strength is a good explanation, but that's about all you can glean from this. I don't know about the specific dating. There's very few. The samples are far and few in between. And just like you said, the magnetic field can fluctuate in a few years and in different places do different things. Like we have a South Atlantic anomaly, for instance.
Right. So, I think it's an interesting theory to think about. It's an interesting hypothetical, and I think it's worth considering. But in reality, the amount of data that we have to actually back up the idea that there was a very weak magnetic field for 26 million years, I don't think that the data is really there for that. I mean, it could be, but it's just an idea. There's so
Right.
much missing in between that I think it's really impossible to make to claim that there's a strong correlation here. It's just, but the concept that a weak magnetic field could trigger heavy oxygenation in our atmosphere, that was the catalyst for a major shift in the atmospheric chemistry on Earth, is really interesting. And it also doesn't exclude the possibility that there was the trigger for oxygenation that lasted despite maybe the magnetic field becoming strong again at some point.
Yeah, because maybe there's a period of time here also where there's huge mid-ocean ridge activity and volcanism that's boiling the oceans, and that's where the oxygen comes from.
Right. Well, also, obviously, we still have a oxygen-rich environment today. It's the reason that we exist, but yet we're living in a magnetic field that is 30 times stronger than what they found at these particular dates. So the change can be triggered. It doesn't mean that the magnetic field has to be weak in order for that oxygenation change to be sustained.
So while all this is going on, the only life on Earth is in the ocean. There is no life on land. There's not even a blade of grass. That doesn't happen until like 480 million years, right at the beginning of the Silurian. The Silurian kicks off when one day a grass emerged. So there was some kind of seagrass that was then above the surface of the water and maybe photosynthesizing or some early version. And then as the water dried up in this one pond, it lived.
Mm-hmm.
And then we go from grass to ferns to fern-like trees in a period of a few tens of millions of years.
Mm-hmm.
That can only happen when the oxygen, I believe, went above between 7 and 14% is when those grasses formed.
Okay, well, that's interesting because, I mean, they're claiming in this paper that the oxygenation increase basically happened between 575 and 565 million years ago.
Yeah, but now you need evolution to get things on land where they never were. So that's going to take time.
Right. Another 100 million years, apparently.
Well, if the earliest fossil that we think is a plant is 480, it's probably earlier than that, probably 500.
Sure.
And that's not much time between so they're saying the oxygenation, what's the earliest date?
575 million years ago.
To when?
565 million years ago.
Yeah, so that's a long time.
Yeah.
65 million years to get out of the ocean now that there's oxygen. But first, what's going to happen is what I said. There's going to be things that are sticking out of the ocean that start to mingle with this oxygen.
Right. Well, and
because they were taking oxygen out of the ocean water, now they figure out how to take it out of the air because it's there.
Right.
Yeah.
But they're also talking about in this time frame, 575 to 565 million years ago, this is the period of the diversification of macroscopic animals.
Yeah, and this is called the Cambrian explosion.
Right.
So the most interesting thing that happens, and I think this is fantastic, is the discovery of Dickinsonia, which is this fingerprint, like the fossil looks like a fingerprint. Here it is here. They're showing it here.
Mm-hmm.
Swimming looks like a trilobite. I don't know if you know what that is.
Yeah.
But Dickinsonia, according to the Russians, they have some really good fossils of it over there. They found cholesterol in the fossilized remains of this creature, suggesting that this is our ancestor, humans. This is the first animal on Earth.
Right.
Absolutely interesting. Because the first animal would be the first thing that makes cholesterol, because only animals make cholesterol.
Mm-hmm.
And so that is their supposition. So you're looking at your ancestor, Leah. Dickinsonia.
Yeah.
Plus, it's just fun to say the name, especially when you're in university and you're teaching a bunch of kids. They all giggle. So there's the actual fossil.
Yeah.
And if it is our ancestor, it looks remarkably like our thumbprint. Kind of weird.
Yeah, I guess. I mean, it looks more like a leaf, right? Just based on the pattern of striation there.
Yeah, no trees for a while though. And this is under the ocean.
Yeah.
So there are also some types of flatworms or wormy-like things and jelloids and jellyfish. as well as early plant-like things, maybe sponge-like things or seaweeds. And it's all pictured here.
Yeah.
And then,
well, and then it's interesting to think too about just, in this time period, most of the oxygen on Earth, as we were just discussing, basically is going to be concentrated in the oceans before it's released into the atmosphere, which is, directly correlated with macroscopic organisms, oxygen levels. Just as a larger macroscopic organism, you need more oxygen to be able to metabolize.
Yep. So this is the date it all happens. So we're in the Ediacaran fauna for a very long period of time. So this is the first, we go from just algae and then algal mounds. That's it for 1.8 billion years. That's all that's in the ocean. Then the Ediacaran happens and all these weird things show up. Dickinsonia, plants, and weird things. And that is 570 to 565 when the oxygen spikes. Well, then we get the Burgess Shale at 508. So it takes 60 million years. Some other cosmic event occurs, and then all of a sudden we now have in the Burgess Shale 50 creatures that we don't even know what phyla they fit in. What is this? This looks like a sickle blade with a handle. Right. There are creatures with 12 sets of legs and 8 pairs of eyes. It's like God is experimenting with stuff that doesn't work. It's just like, oh, that's stupid. Why do we need 16 eyes?
Right.
And so the Burgess Shale is this blip in time that's unexplainable, where we have another explosion about 60 million years after the first explosion. And then a few 10 million years after that, things go out onto land and it's all over. It's all she wrote. Within 100 million years, there's land animals everywhere and the dinosaur. Absolutely insane.
Yeah.
The history of Earth.
Yeah.
And people want to shrink the length of time. There's a lot of creationists that think that the millions and billions of year discussion is actually, the Earth is only tens of thousands of years old.
I think that it's partially that idea comes out of this sense that like God's creation doesn't exist without human beings or something like that, which I don't agree with at all, right? Like, I think God's creations can be anything you could possibly imagine, and that's sort of the whole point, because God is infinite. So it doesn't necessarily have to include us.
No, especially if we were once Dickinsonia.
Right.
And it says here that Dickinsonia is a genus of extinct organism, most likely an animal that lived during the late Ediacaran period in Australia, China, Russia, and Ukraine.
I mean, it's interesting that we can't even definitively say that it's an animal unless you want to make that distinction of the cholesterol.
Right, which Western scientists, they don't believe the Russians, obviously, but I think that has something else to do with something else.
Like the Cold War that never ended, apparently.
Yeah. So we do have some interesting morphologies. The idea of how this creature grew is interesting because then it goes to all of the other ring-like or layer-like creatures like clams that grow annually by adding. They're suggesting that this is where the annual addition is and things move away from the center. So you can learn how many years old it is by counting up these rings.
Cool.
Some of the Dickinsonia, I believe, are gigantic. They're, I don't know if they have, yeah, 1.4 meters, 4 foot 7 inches. So some of them are big.
Wow. That's a foot shorter than I am. That's huge.
And they were probably some kind of creature that's just cleaning up the bottom.
It makes me think of like a stingray as well.
Yeah. So pretty interesting stuff going on. Now, the reason we should tie this all together, the show's about to end, is that if this is true, we've got the magnetic field weakening, we've got cosmic rays coming in for long periods of time, and it's creating these explosions in new species. This is what we've been talking about for years. Yeah. And more corroboration that we're probably all aliens. The first thing to get here came from an asteroid, like a piece of algae, and then all of this happened through cosmic radiation.
Right.
So it's not all bad. We may
No.
be entering the next extinction event on Earth, but we know about it. We know not to go outside during the day if it gets bad.
Well, and
we've
also,
made it. Go ahead. We've made it through all these many times.
and wherever there is death and destruction, there is also new life, right? I mean, this is part of the circle of life, and it's unavoidable that these two things, death and life, go hand in hand.
And look at what the field strength does all the time. It goes up and down. And each of these bottoms is a mass extinction event and a proliferation of species.
Mm-hmm.
And typically, when it falls below 4 on the VADM here, we get an extinction event. And we are now down close to 4.
Exciting times ahead. Find us tonight on Magnetic Reversal News at 8 p.m. Mountain Time on YouTube.
Be safe.
Listen to Revolution Radio at freedomslips.com, and we'll be right back after this message.